right? So let us go to our 3D model, students. Now students, let us try to understand the idea of centripetal force by using a very simple model here, okay, which you can relate to you in real life. Here you can see the man here is trying to whirl around a ball which is tied to a string. He is trying to rotate a ball which is tied to a string, as you can see, okay. Now obviously in order to start the rotation we have to move our hand. We have to pull our string as we are rotating, or as we are moving our hand also. The ball is going to rotate like this. Okay, it is going to go round and round and round and revolve like this. So what is that force? What is that force which is keeping it in check or keeping it regularly in orbit? That is the centripetal force or center seeking force. Clear, students? So here we can see the ball's path like this, which is being drawn in the animated model, right? So the velocity or the direction of the ball at every instant the velocity is changing. Okay, see, circular motion, we have already studied that circular motion is an accelerated motion. Why? Because its speed is constant, but the direction of its motion is changing always. There is an accelerated motion, right? The velocity has two components, magnitude and direction. Its magnitude is speed, which remains constant. It is moving at constant speed, but its direction is changing, so it can be said that it is an accelerated motion. Okay, circular motion. So here you can see, students, as it is being shown in the model, the direction of the velocity is always tangential. It is always tangent. What is the meaning of tangent, students? Tangent means it is any line which touches the circle at a single point like this. Okay, this is called the tangent to a circle. Okay, any line which touches the circle, okay, at a single point is known as tangent. So tangentially the direction of the velocity always remains in case of a circular motion. All right, let's play it forward. All right, now what is the force? That there must be some kind of force which is causing it to change the direction. Okay, because if there was no centripetal or center seeking force, the ball would have just flied away tangentially, right? So the centripetal force which is acting towards the center, which is being denoted by the orange line here, it is keeping the ball in check, it is keeping the ball in orbit. Now students, what will happen if we cut it? Now the ball is rotating, right? What is going to happen when the string is cut? Here you will see that the moment the string is cut, students, the ball is going to travel tangentially. Okay, the moment the string is cut, let me play it again. The moment the string is cut, the ball is going to travel tangentially. It is no longer going to travel in a circular manner like this. Why? Because the center seeking force, the centripetal force, was the one which was constantly changing its direction, which was constantly making it stay in a circular path. But right now, since the centripetal force is lost because the string is cut, the string is the one which was providing its centripetal force, right? It was the one which is holding the ball. It was attracting it towards the center. So now the ball is going to fly tangentially. Okay, let us go through it again, how the action is going to look like again. All right, the ball is going to fly away tangentially the moment it is cut, right? Okay, now let us understand centripetal force through a simulation, okay, where we can again change the parameters and try to understand it in a better manner. Okay, all right, so here we have again an object with us, right? So if I start the animation, you can see again the same thing is happening. The object is moving. Here you can see the acceleration vector. The orange is the acceleration vector. Okay, the red one, here you can see the red one is the velocity vector, or the direction of the velocity. The direction of the acceleration or the direction of the centripetal force is towards the center. Here you can see it is written on the left hand side. If I want, you can show the force vector also. Okay, the green one. I can switch off the acceleration vector. If I can show the force vector, which is the centripetal force, it is acting. We are studying about centripetal force right now, right? The green one is centripetal force direction. The pink one is the direction of velocity at every instant. Okay, as you can see, it is changing. But once we resume the animation, okay, wait, let me reset it. Once we resume the animation, you will see that the force is always acting towards that center. Here also we can cut the rope, students. Here also we can cut the rope. Let us reset and start the animation again, and there, the moment I cut the rope, the centripetal force, the green vector, the force will vanish. There will no longer be a centripetal force, so the object is going to fly away tangentially. We just discussed what is the meaning of a tangent. Let us start the animation, and let me cut the rope, let's say here. See, the moment I cut the rope, here you can see it forms a tangent. It goes away tangentially. It no longer stays in orbit. Okay, let us reset and try it another time. This time, let us decrease the velocity slightly. Okay, let us increase the radius of the circle. Okay, and increase the mass of the object. Okay, so of course you can see as mass is increasing, the centripetal force is also increasing. We have changed the parameters. Let us see how the motion is going to look like now. Just a moment. Right, now let's cut the rope now. Yes, the moment we cut the rope, you can see again the object is flying away tangentially to the circle. That means clearly there is some force which is keeping the ball in circular motion or in orbit. Get my point, students? Now, remember we were talking about why the planets and why the moons, they always stay in orbit. Why are they not crashing into each other? Let us discuss this again with our rotating ball 3D model. Now students, what used to happen previously when our solar system and other heavenly bodies were formed? They were all in random constant motion. They all had their own velocities previously. So when they formed, right, they are not at rest. Nothing is at rest. You can see the sun, it revolves around the Milky Way, right? The moon, it revolves around the earth, isn't it? Let's say this is the earth, it revolves around the sun at the center. So they are all in motion. So sun is not stable. If the sun was at rest, all the other planets would eventually crash into the sun. But the sun is itself in motion. Okay, and actually the planets are actually flying or getting pulled towards the sun. But by the time they reach there, the sun has already moved its position. Okay, so actually what happens is they kind of tend to miss the sun, okay, or miss the greater heavenly object. So they remain constantly in motion, round and round and round and round, they remain constantly in motion. Now tomorrow if something happens and the sun loses its motion, the sun remains still, all the other planets will come crashing towards the sun. The same thing happens with earth. The moon is also constantly falling towards the earth, but since the earth is also moving, by the time the moon is reaching the earth, it misses the earth. Okay, it's like kind of a miss, and again the same thing happens. It keeps on rotating, or you can say revolving, or keeping in orbit around the earth. And what is the earth doing to keep the moon in orbit? It is the gravitational force in between the earth and the moon, right? So I hope all of us understood the concept today. Let us do some problems and we can discuss further concepts in the next session, right? Let us do some problems. Now, what is the definition of centripetal force? The force that causes an object to fall toward the earth, the force that keeps an object moving in a straight line, the force that keeps an object moving in a circular path directed towards the center of the circle, or the force that causes an object to stay at rest. Very simple question, students. The answer is the force that keeps an object moving in a circular path directed towards the center of the circle. The centripetal force is always towards the center of the circle, right? Now, what force provides the necessary centripetal force for orbital motion in celestial bodies like moon, earth, sun, other planets? Is it electromagnetic force? Is it gravitational force? Is it frictional force, or is it nuclear force? It is, of course, it is a gravitational force. So I hope all of you enjoyed today's session. We are going to be learning more about like other concepts from gravitation chapter in the next sessions. Okay.